Having discussed single-player games, let's turn now to multiple-player games, such as chess and Othello and Go and Chinese checkers and so forth. In most cases, the other players in these games are general game playing programs themselves, or in some cases, humans. However, in some cases, the other players represent uncertainty in the game. For example, it's common to model some card games by representing a randomly shuffled deck of cards as an additional player in the game, one that deals or reveals cards as the game progresses. Before proceeding, it's worth emphasizing that multiple player games need not be fixed sum. In a fixed sum game, the total number of points is fixed. When this number is zero, such games are often said to be zero sum. In order for one player to get more points, some other player must lose points. For this reason, fixed sum games are necessarily competitive. In general game playing, there's no such restriction. Some games are competitive, most games are competitive, but some are cooperative. It may be that the only way for one player to get a higher reward is to help the other players to get higher rewards as well. These are sometimes called variable sum games. In this lesson, as in the preceding lesson, we look at settings in which there's sufficient time for players to search the entire game tree. That said, as in single-player games, it's sometimes possible to find optimal actions even without searching the entire game tree. Now, the small size does rule out some interesting games like chess and Othello, which require more complicated techniques, and we'll discuss some of those later. However, again, the more complicated techniques can be viewed as variations on the simple techniques described here. We begin this lesson with a procedure called minimax, and a more efficient version called bounded minimax. We then turn to an even more efficient procedure called alpha-beta search, which produces the same results, but eliminates much of the needless computation of minimax and bounded minimax. There's also an analog to sequential planning called conditional planning. However, it's a little complicated and it's not used all that often, so we'll bypass that for now.